Hello everyone, thank you very much for joining our Tales in Tech DevOps discussion webinar. My name's Oliver, I'm a technology recruiter working within the DevOps and SRE team here at Bernstein. Today I'm joined by Luís Sousa. Luís is currently the head of DevOps and SRE at GDC. Over the past 7 years, Luís has been a specialist in DevOps and SRE consulting and cloud transformation projects. In the past few years, he's been building and guiding teams of platform engineers, maintaining environments on AWS and GCP. And as such, today he'll be sharing his insights on infrastructure as code and the pros and cons on IaC repository strategies. So welcome to you, Luís.
Thanks, Oliver. Nice to be here.
Nice to have you. Thanks for joining. So I'll hand over to Luís for his presentation now. We'll follow up afterwards with a Q&A. I would encourage those on the call to submit your questions in real time, and Luís will do his best to answer those questions as he goes through. If we're unable to answer those questions, we can revisit them at the end. So, Luís, over to you.
Thanks, Oliver. Welcome, everybody. Nice to have you all here. So I'll just share my screen here, and hopefully you will be able to see my deck. There you go. So welcome everybody, and thanks Oliver for the intro. My name is Luss, as mentioned. I've had over 7 years in the industry of IT services and consulting. I originally started a bit as a middleware developer, and so my background is mainly on integrating solutions and making them actually work across the board. Having cut my teeth with Oracle products, I think the experience with those has kind of proved very useful. In integrating a hodgepodge of new technologies and even legacy technologies to work together in an automated fashion. And for the past 6 years, in one way or another, I've been either consulting for clients or building teams for end customers or for even my own purposes around the DevOps and SRE areas, working with technologies and cloud providers such as Azure, GCP, and most recently AWS. So I have kind of quite a broad base of providers and technologies. For the past few months and years, I've been focusing mostly on Terraform and how to use infrastructure as code combined with CI and CD pipelines to actually automate the most out of our infrastructure and try to drive that kind of high availability and resiliency. So I have a bunch of opinions and capabilities that I think I can contribute to the community. But it's worth pointing out that these opinions are just that. They're opinions based on experiences that I've had. And even though some of them are strong opinions, I usually have them as a loosely held ethos, meaning that if you have a better use case or if you have a better situation that you think that my solution or my opinion doesn't fit to, I'm more than happy to hear about it and see how I can modulate these kind of solutions and architectures to your particular business case. As I usually say, the best solution is the one that usually fits your team's needs, and you have to be risk averse, but at the same time you need to have the willingness to try new stuff and to try to break things. Otherwise, you won't push the boundary of what you need to do. And unless you've been living under a rock and you haven't interacted with any consultants in the past, you'll probably see that any questions or that any answers that you may ask. And answers that I might give will probably start with the sentence, "It depends," because that is probably the case, that everything that we trying to design for, trying to solution for, usually depends with the conditions that we have around us. So today, I want to talk to you a bit about the main challenges that we have when we're speaking or when we're trying to implement solutions for infrastructure as code repository strategies. There are two main schools of thought around this area, and you'll probably see a lot of parallelisms with software development philosophies or development strategies as well, where there was a big debate, or there still is, but there has been a big debate on having your services all in a big mono-repo and having them tiered there so that everybody can commit to trunk or doing branch-based development. But there's also the philosophy of having everything split up into neat little repositories and modules that can be reused and that can be transferred across the board and referenced to using version control systems in a right way. For infrastructure as code, this debate is a bit different. It's a bit different because not everybody is going to be having access to this, and at the same time, you're going to be working with sensitive information, i.e., secrets and infrastructure architecture design that you actually don't want everybody to be privy to. Another part of it is that if a service of yours gets damaged, then usually what ends up happening is one of those services, it's the only thing that breaks. If you actually end up damaging the infrastructure repositories, that might have broader impacts, and it might impact a whole host of people. So usually, whether you go with the mono-repo or multiple repos, the governance and the security around these infrastructure as code repositories needs to be airtight, and you need to have at the same time the ability to collaborate with other teams, but at the same time you need to have the controls and security in place. I myself am a proponent of the solution of it depends for your situation. And what I usually mean by this is that if you're a startup and you're just starting, and you have a small estate, concise estate that is composed of one product that is well defined, or that it's being defined as you go along, usually you're better off with a mono-repo that fits that particular need. But if you have a biggie enterprise that has multiple teams, each one responsible for their own components, then you might be better off with a multiple repo solution. However, this is not the end all and be all of the design and the actual ethos of the question, because one of the things that you have to keep in mind is the more components you spread out, the more dependencies you have to manage, and the more governance and life cycles you have to manage. So in some circumstances that I've seen, the mono-repo, even with a big decentralized team, might work out for you well if you have the proper governance and controls in place to help you out. So where do we start with this journey? Right? And I usually start with a few questions and a few considerations that actually drive the design process for the infrastructure as code repositories. And the first few questions usually have to do with your architecture and your kind of existing processes if you have some. So I usually start with what's the complexity of your infrastructure? And what I usually mean by this is, are you running a POC, or are you running a multi-tiered, multi-region, highly available architecture? And the reason why I ask this is because depending on the complexity of your infrastructure, you'll have different moving parts, and you probably have different owners. Usually you don't have just one team managing a highly complex infrastructure. In my experience, if you have a global network or even a region alone, but multiple AZ network, you'll usually have a team or a subset of your team that is responsible. There are SMEs in network. If you have a bigger infrastructure and bigger architecture, you'll probably also have a team that's dedicated to security, and security either OPSEC or AppSec. So those teams will also need to be involved in owning a part of your infrastructure as code. Or you might be in a bad situation where these teams are not yet involved or not yet brought on board of these on this journey of having everything as code. In that case, there's even a bigger sense of having teams brought in and controlling and giving them the sense that they're in control of their domain areas. And with that being said, you also have to consider how often you want that infrastructure to change, and also what kind of control and quality gates you want to have for that change to happen. And this is particularly important on the size of your estate and the maturity of your processes. If you have a startup situation where you want to go as fast as possible, you want the process to be as lean as possible, and at the same time have as many quality controls that will enable you to deliver safely to production. If you're a big enterprise, you want to have the most amount of controls in the verification that all those controls have been met, and usually you also have a CAB, even though I don't agree completely that these situations lend themselves well to a CAB control process as we know it in the ITIL framework. But at the end of the day, one of the things you have to keep in mind is you have to balance the controls and the quality at the same time as the speed of delivery that you wanted to go for. So if you need to do hourly changes, or if you need to do weekly changes, your infrastructure repository will have to adapt to those kinds of needs. And more than anything else, it will have to grow as your processes and as your architecture grows. One of the things that I also like to keep in mind is what platforms and services are you going to be using or are you planning on using with your architecture and with your infrastructure? And what I mean by this is, are you planning on using multiple cloud providers? Are you planning on using external DNS providers like Cloudflare instead of Google DNS or AWS Route 53? Are you planning on having your providers all bunched in the same area, or do you want to have different parts of your infrastructure as code focusing on different providers? I'm usually a big proponent of having the components and the providers that are needed for running a particular environment in the same logical area that they need to be co-run. And what this means is, if I want to make, for example, load balancer change, and for example, I use Cloudflare as a DNS, as a CDN, I want to be able to run the load balancer creation and at the same time have an API call being run to Cloudflare, so that you can update the DNS records on the go, so that those two are tied together. Some teams and some organizations will have different teams that manage these two different things separately, so you might have to account for those kinds of things. And that kind of ties into the logical separation of environments. How do you plan on making changes between development and test and stage and prod? Or do you have different environments for different brands? Are you doing a multi-tenant hosting solution? Are you doing B2B, or are you doing B2C? So are you providing straight to the end customer? All of these things have a translation to a hierarchy in your repository structure. And I will show you a few examples of this. And finally, but definitely not the least important, is how will you be managing your secrets? I'm a big proponent of using tools like HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, Google Secrets Manager. But you have to keep in mind that these tools need to be managed, and the last thing you want to do is want to have a secrets in code, because the last thing you want is for somebody to erroneously push a repository where they shouldn't, and in that case, your secrets are all out there in the wild. So one of the things that you have to bake in from the ground up is how to integrate your credential management tools for your environments. And then that has a broader implication, which is how do you give access to these secrets to other teams that will inevitably require them. So let's walk through some solutions of what not to do. And this is usually where I like to start, because that's usually where people end up having the most problems. So in this particular demo here, I have a folder, and hopefully you can see this, which has a complex set of services. And what usually, or repositories, and usually what these end up being, and if you've ever worked in a company that has a lot of infrastructure across the board, you'll end up seeing people coming in for short stints, either contractors or permanent people that are just passing by, and they're required to develop something that is actually delivered, but then it's poorly handed over. And this is an example of a situation where you have multiple repositories that people have come in, deployed, and then handed over, and you have to maintain them. One of the situations that I've seen more often is you have an infra stack repository, or you have an infrastructure repository, which will have some components and will have nested folders inside of it. But then you'll quickly outgrow this, and you'll start naming things as legacy, or you'll start naming things as other things that you have. And you see there that there's one folder there that's key. So that's something that I would definitely not recommend you having. As soon as I see a repository that says infrastructure and it has keys in there, that's a complete red flag and a complete alarm for me. So I usually try to tackle that as soon as possible. But one of the things that this architecture might be the most egregious on is actually on how it references components between stacks. And let's take the infrastructure services repository here. There's a few services here. And one of the things that you'll probably see here is it has a folder for each service. Okay, fine, well enough. what that means that essentially the services are logically separated. But if I want to go pick up a service, and if I go check their repository here, well, it has a bunch of information here, but it actually mentions a repository elsewhere, right? And when I say, what is this, right? It's a repository, but then it references the repository and a folder inside said repository, and it mentions a branch inside that repository. And that branch is not even pinned to a particular version. It's only pinned to the branch, which usually is a bad thing to do, and something that you should avoid. The reason why that is that as soon as somebody makes a change to that branch, the next time you run this Terraform code, you will inherit those changes without any controls. And this is a very, very dangerous position to be in. So I usually recommend, if you're going to go for a source-based control in management lifecycle for your Terraform modules, you should at the very least pin it to a particular version, either using semantic versioning or using another versioning methodology for you to do that. Another thing that we can spot here is that it's pinning to another repository. And that's not the worst thing in the world. However, if we do go into that modules folder, we'll probably see something that we're not very happy with. So we'll go into our legacy modules here, and then we'll go into our legacy services. We'll scroll down, we'll see all the code that defines this module. And in the end, we'll see, wait a minute, this module will inherit another nested module that is in a different repository, in a different folder, in a different branch. So this is where the nightmares begin. And why do you end up in a situation like this? You'll usually be in a situation if you've tried to over-modularize everything, and if you've tried to make everything as reusable as possible. The problem with that strategy and with that complexity, and trying to keep it dry as much as possible, is that you will have inherently an attrition to making changes. Because now, if I want to make change to this service, either changing to a new different load balancer type, then what I'll have to do is I'll have to go to the third repository structure. I'll have to find what I'm looking for, change in this particular scenario. If I needed to change the name or to change the ALB setup, I'd have to change the ALB, commit this change, tag it to the right place, go back one level, change the tag for this submodule into, for example, v1.3 or 0.2.3, commit this change, have it approved again, and then go and promote this change across the board into my main services repository. So all of these steps have inherent problems with it. One is the sheer complexity. Second is they're not easily testable, and you can't easily predict the impacts of such a change across your whole estate. And I think the most important of this is the most important issue with this approach is that when you're trying to onboard new team members, or when you're trying to train people up, and having this become part of the status operating process, the standard operating process, you either have to have this extremely well documented and foolproof, or you will have to spend considerable operating hours and resources shadowing and peer training people to actually follow this process correctly. And the more complexity you have, the harder it is to troubleshoot when inevitably it does go wrong. So these are just a few of the considerations I have, and a few things that I recommend you not doing. Other things that I can say off the cuff that you should try not, or you should try to avoid, is if you're trying to do everything in a mono-repo, try to avoid symlinks, try to avoid having any kind of structure that will cause or that will induce people into getting confused about how they're implementing. Because keep one thing in mind, which is you will design something with the concept and with the information that you have of knowing what the architecture is, but you also have to put yourself in the position of somebody that's coming in fresh and needs to pick this up and run with it. So documentation, keeping it simple, even sometimes at the trade-off of not having it as dry as possible, but keeping it simple usually is a better option for infrastructure as code. So with that in mind, what are a few solutions that we actually should look at? And I usually have, like I've mentioned in the beginning, I usually have two main approaches to having my infrastructure repositories structured. And on the left-hand side here, usually it's the two repository strategy, one which will have your infrastructure and your definition of environments. And usually I'll split this into the logical components of a particular architecture. So in this particular case, I have the base infra stack, and that usually covers the network, the routing tables, and all the boundaries that I need to have, and all the basic naming conventions. I'll usually also have a base security stack or a base services stack. And these are usually the components that are handed over to particular teams that will have to maintain these. The security stack obviously goes without saying, and the services stack usually is the one that you end up having delivered to teams of developers, and testers, and QAs that need to make changes continuously, either to tweak parameters or to actually perform releases across the board. And then you have a Terraform modules repository that will have the core components for that particular organizational unit that are going to be reused for them. And why do I say for them? Because it's easy to get into a pitfall where you try to create enterprise-wide Terraform modules. And essentially what you're doing there is you're abstracting the primitives that Terraform providers already give you. So in this case, I have an ALB module, but this ALB module doesn't try to cover all the different permutations that an ALB can have, right? You can have an ALB per service, or you can have an ALB with multiple listener rules that will then route you to different services. We try not to abstract the modules to be the end all and be all. This is why I say that you should have modules that fit that particular project or that particular team that are using them. And if you find yourself having modules that are too widespread, then maybe it's the right time to start thinking about going back to using the primitives and putting controls around the use of primitives, like naming conventions and checks on other components. Because what you will inevitably find yourself in a position is that the provider will be updated in the background, your module will not have been updated, and then as default value gets snuck in without you noticing. And you only find that out once you're trying to test something later down the line. So do try to keep your modules right-sized and fit for purpose. Don't try to modularize everything. The other approach that I usually like to take is the mono-repo for logical components. And what usually this means is that you want to have mono-repos that are not hugely big, insanely big. What I've seen in terms of mono-repos is that they become so big and so riddled with legacy code, older versions of Terraform or even other tools. I've seen Terraform, I've seen infrastructure repos that as code repos that include Ansible, that include Jenkins, all mishmashed in one single location. And usually that ends up having not only a performance impact on operations with Git repositories, because those changes start adding up, and if you're not doing rebases and squashes frequently, your repo will get out of hand. But when you're in time, when inevitably it's the time to do a large scale upgrade from a Terraform version 11 to 12, or now that we have 12 to 13, that's going to be released soon enough. One of the things that you have to keep in mind is that you want to be able to roll out change without having a whole lot of long-lived branches. So usually what I end up having is the mono-repo for logical components. And usually these will be, for example, the mono-repo for our infrastructure tooling. So all of our tools like or Jenkins's or GitLabs or Sonars or our Vericodes, all of this will be in a logical place. And I have a few examples of that. So if I go back to my screen sharing here, and if I go to the complex, to the simple structure, you will see that usually these are smaller repositories. And one of the things that you usually end up having is a Terraform infrastructure repository, which will have your README and your Terraform setup, as I mentioned before. And in this one, you'll still have your infra security stack or your base operations stack. And inside that, you can either go via a branch-based vars, or you can use Terraform workspaces, or you can actually have the state files being separated by S3 buckets, or having a different lifecycle on these vars. But essentially, what this allows you to do is it allows you to have a common code base for your infrastructure as code, and then the only thing that changes are the vars for the environments. In this particular case, I have a few services here, and on these services I have all the vars for that. And you'll see that from one environment to another, most likely what will change is just the actual components that make up the environment in particular. Another folder that I have here are the modules, and these will actually have the actual modules and the reusable components, each one of them with an accompanying README file that will help the developers and whoever's using this to actually use the module if they need to go down. And the lifecycle and the governance that you put around this is quite important, because it will allow you to make changes and to promote changes, to verify said changes when you try to implement your peer review requests and your pull requests if you're using Bitbucket, for example. And then finally, the mono-repo solution is, for example, one here that I have for our CI and CD tool, in this case Jenkins, but it can be GitLab, which we have also. And for example, this repository will have the orchestration folder, which will have any kind of repositories or roles that we need to run there. It will have the main code for this piece of infrastructure. So that's going to be the Jenkins infrastructure. And it will have the vars for every single instance of this repository that I have. So in this particular case, we have a green-blue implementation. So in this case, you're seeing the green vars here for this green var Jenkins. And it also has a Jenkins file because it can run itself on top. So we have a Jenkins that runs the Jenkins Terraform code to set up other Jenkins instances. So having a simpler mono repo for this particular logical component will allow you to have everything in here, everything self-contained and easy to update. So if we need to update this from Terraform 11 to Terraform 12, it's quite easy to do. So one of the things that I usually like to end up with is try to answer what are the kind of trade-offs and actually compromises that you're making across the board. Usually by having, I've usually been asked, well, isn't the best practice to keep everything dry and separated and componentized in a position where you can just give it to anybody in the company? And the answer to that is yes, but not really later down the line. And the reason why that is because, as I mentioned before, these technologies are still evolving and you'll have to update them quite frequently, as well as the providers behind them will be updated frequently. AWS or GCP will be continuously releasing components that the infrastructure as code providers will be updated underneath it, and you will inevitably have to make sweeping changes across the board to fit that need. So one of the things that I want to instill in you is that by having many more steps and having too many more things to update, you're actually shooting or preparing yourself to shoot yourself in the foot, because you'll have a harder time upgrading, and you would inevitably be in a position that you'll leave stuff in older versions of the code. One of the other things is be careful of having very complex approval processes for this. The reason for it is because the longer you have your branches waiting to be released across multiple environments, the more likely it is that changes will start conflicting with each other later down the line. And usually these might give a sense of safety for your governance and controls board, but usually that ends up having, you'll need to have smaller chunks of changes being pushed more frequently in order to make that happen. And I think the last but not least is, as you can see from this XKCD, is the more commits you have to do to make a particular change, usually less helpful the commit messages end up being. And I for one am a big proponent of having as many commits as possible needed to make a change, because I myself will start becoming quite handsy at having to commit 10,000 times to make one particular change. So yeah, so in this lightning talk, that's all the time I have for topics, and I know that people have been will probably have questions, and we have the Q&A now. So do feel free to ask any questions. You can find me on Twitter and on Medium, and if you want to read any other topics, please feel free to hit me up there.
Thanks very much, Luís. That's incredibly insightful talk. We certainly do have a few questions for from the audience. So the first one: what's an example of specifying a specific version of a repository example versus just using a branch?
So that's a good question. So in this particular scenario, if we go, for example, into this services repository, if I go to services here, you'll see that the ref in this particular Terraform module is pointed to a branch. And if I wanted to do this properly, if I was going to recommend and redo this repository, what I'd actually do is I'd put this tied to a version like this. And what this will allow me to do is it will allow me to pin this particular change on this particular environment to a version of the module. And by following this process, that means that whenever I merge or I approve a merge request on the modules repository, and I get that tag to 1.3.4, even if somebody runs this repository here against an environment, that change won't get accidentally pushed into production. Otherwise, if I had this on the staging branch, anytime a pull request got approved against the modules repository and this was ran again, this change could slide in unnoticed by mistake. So this is not something. This is the kind of difference that I would highlight here.
Excellent, thanks, Luís. There's a few that are coming in now, which is great. So do you have any recommendations for Git practices, commit message formats, branching strategies, etc., with implications for an info repo complexity?
For sure. On the Git practices, usually it's always nice to have pre-Git commit hooks where you're enforcing, if you can, either at server side or at local side, that your Git messages follow a ticket number plus a meaningful message format. That's usually something that I am a big advocate for. On the branching strategy side of things, I usually like to keep it relatively simple. I've seen setups where the infrastructure repository the infrastructure repository follows a branch per environment, and I have an example of that here. So my infra stack here on the left is currently on the stage 0 environment, a stage 0 branch. And if I do a git checkout tst2, for example, I might need to do a git reset here. Second. So if I do a git checkout for test2, I'll check out all of the components for that particular environment. I don't usually like this option because doing git diffs becomes useless, because these environments will be so different because of different repository, of different modules and different variables. Usually it's more noise than useful. So I'm a big proponent of the two branch strategy, where you have your master or your main, your development, and your main is going to be essentially, your master is going to be your production level components, and your development is going to be where you're trying new stuff with. But even then, I would recommend, if possible, go to a trunk-based development as early as possible. And what this will allow you to do is it will force you to develop governance capabilities to do small incremental changes quite frequently and input the controls that you can run as fast as possible through the lifecycle. So your compliance teams might want to have as many branches and as many approval gates as possible. I, for one, am a proponent of the simpler trunk-based approach, because even for massive refactorings and for upgrades, it will make it much easier to just have a short-lived branch that allows you to upgrade the components in a staggered way, but in a controlled fashion.
Luís, what's your advice for testing infrastructure as code? Is unit testing Terraform code a thing? Functional testing, do you scale testing when the infrastructure gets bigger and bigger and bigger, essentially?
Yeah, so there are a few ways of doing this. The more common ones are external Python libraries or Ruby libraries like RSpec that allow you to write the tests. However, what I've found is that the initial barrier to entry to these is quite high. So what I've usually found is that a low-tech NASA-based checklist approach usually ends up being more effective for smaller teams that don't have the time to write all of these infrastructure as code tests. For bigger teams, then what I'd recommend is probably the Terraform Cloud governance components that they're rolling out now. These include policies as code, which are amazing and allow you to block most of the changes that you wouldn't want to have in production. Or if you don't want to go with a paid product, there are a few cool open source projects that do governance and compliance checking after the fact, meaning that, for example, you can set up policies in your providers that if your infrastructure is not tagged in a certain way, or that if it's using an instance type that you don't want to be used, it will automatically terminate. So you can enforce those changes after the fact. So it depends on your approach and it depends on your level of risk appetite. I think a combination of both preemptive checks and post-apply enforcement usually works out the best.
This is an agree or not question that came before, but Terraform simplicity is a big plus, but can sometimes lead to lots of repeated code, which can be a hassle to mitigate.
Yeah, so I agree completely, and this is part of my argument here for trying to keep it simple, as opposed to dry. It's okay to, in my experience, it's okay to repeat the code if it has a value purpose, and if you're going to be having people that are going to be focusing on that particular piece of code. And what I usually mean by this is, depending on your org structure, and these two are intrinsically linked. If you're going to have a position where you have teams dedicated to keeping this up, then it's fine to having repetition in code, because that means that the code will fit the needs of those particular projects and teams. If, on the other hand, you have a very wide platform, a very wide-ranging platform team that is supposed to cater to everybody and anybody, you're better off in that case having a concentrated repository of those modules. But then again, keep in mind that there's that other pitfall that I mentioned, where you have too much modules that are so abstracted that they end up not having any purpose, because they're so complex to implement anyways that people end up not using and end up developing their own. So you need to try to find a way to straddle that line. But it's a question, unfortunately, that it depends on your org structure, it depends on your processes. But I usually am inclined to go to the repeat yourself a bit, if it will make your life and your upgrade structure later easier.
There's a few more. TerraGrunt makes modules very much first-class citizen. What's your opinion on TerraGrunt in relation to its very opinionated views on directory layout and its module-first approach?
I've used, as you probably noticed in this complex example, I've used TerraGrunt before. I find it amazing. However, you will, if you don't keep it under control, you will end up in a position of having nested modules to the nth degree. And that, I think, is the situation where one of the pitfalls that you might want to avoid. TerraGrunt is great to managing all those different dependencies, but I've also found myself in situations where I had to update 10 different modules just to make one particular change, because TerraGrunt was nested so deep into these modules that it was a nightmare to troubleshoot and to test and to maintain a change. So TerraGrunt is great to standardize your Terraform repository structure. It's as valid as the one that Terraform advertise on their wiki pages. However, before you go down that road, try to have a smart conversation about what your modules are going to be, because the last thing you want to do is to have a TerraGrunt repository structure And then you have a stack, which employs, or which Terraform then calls a stack module. And the stack module will then get a network module, and the network module will then get a route table module, and that the whole thing is a nightmare waiting to happen when we eventually need to upgrade all of it.
There was another question actually, Luís, that came in before. Someone wanted to see Terraform best practice for deploying from dev to higher environments, all the way through to production using CI/CD. I think it was one that they didn't really understand. Perhaps you do. You could provide a bit of insight on that.
Yeah, absolutely. There are many different ways, and I think that topic of CI and CD would cover its own talk in and of itself. I have written a blog post on Medium, which you can find on the slides here, medium.com/@notreallyluis. And that blog post goes into an example where you can use the Terraform Cloud free tier to set up your CI and CD pipeline as an easy, low barrier to entry approach. I, for one, am a big proponent of having either GitLab CI or Jenkins do those kinds of controls, but I found myself gravitating more and more towards the Terraform Cloud approach because it's a simple enough approach. It's a structured way of using Terraform workspaces and of managing state files that I find it very easy to use and very, very easy to actually get changes promoted. But if you'd like to see a session about that, speak to Oliver and demonstrate your interest, and we'll probably put that together. But my Medium blog post on that is a great way to start on that journey.
Great. And just on that, Luís, are there big differences that you'd recommend in approaches for targeting premise infrastructure versus cloud-based infrastructure?
For Terraform itself, no, because if you're using Terraform for on-prem infrastructure, you'll probably have the same security and governance control concerns that you'd have on AWS or on GCP. You're still going to be managing, if you're talking about on-prem VMware, you're still going to be managing NSXT or vSphere. From Terraform, you're still going to have very root level privilege there. So you want to have as many controls as possible on your infrastructure repository, just as you would with an administrator or a higher privileged user on AWS. It's the same risk factor. What I would say though is that because you're going to be targeting on-prem infrastructure, that usually means that you're going to be using on-prem agents to make the changes affect the changes to your on-premise estate. And usually what that means is that you'll have to have a different orchestration architecture so that you're able to push those changes. Whereas with a cloud-based GCP, AWS, Azure, Oracle Cloud, you can use cloud products to push those changes, and you need less information to be living inside of the repositories because those will live in the cloud tools. If you're going to target an on-prem solution, it's harder for you to, for example, use a secrets manager. You'll probably have to use an on-prem vault because that instance or that run will have to be run on-prem, and that will have to target an on-prem stack that will have all the information that you need.
And is there an obvious place to integrate security into the Terraform code, or is that better managed externally to the Terraform automation?
A bit of both. So as I've mentioned, I think governance as code is a great way to start with those security. So Terraform has released Sentinel on their cloud products. And Sentinel is a really good way for you to ensure that nobody opens a security group to 000 or nobody makes a bucket public. And you can enforce that at the plan level or at the apply level, meaning that you'll never allow those changes to go through. If you don't want to go with Terraform Cloud, there are other components that you can use. You can use RSpec, so a set of tests that will inspect your code, and it will fail your pipeline if it finds those kinds of things. I've also found that the enforcement goes really well in hand in hand after the fact. So after you apply, it's really good to have a cloud auditor tool. There used to be the compliance monkey of the Simian army that's been deprecated, but you can use with cloud custodian, for example. It's a great open source project that integrates with your cloud provider, and it automatically looks for and enforces compliance standards, security standards. So you can just reap and take out stuff that has been provisioned by mistake or even maliciously before it affects any change.
Final two questions then, Luís. Is there a way to bulk import the state of current cloud subscription into a Terraform state?
Not easily. You will have to do a bit of automation to do that. However, what I've usually seen is that if you're going to import a large estate, you're usually better off coding it from the ground up and then migrating into it. Why do I say that? It might give you a bigger piece of work to do in the beginning, but it will serve you for two purposes. It will serve you for the purpose of restructuring your infrastructure as you'd like it to be, as opposed to how it has organically grown. But it will also help you with disaster recovery and resiliency testing, because you will be forced to do data migrations and data changes. And that is inevitably a good thing to have. If you don't want to do that, the best way to do it is targeting it on a modular basis, whereas you start coding your infrastructure and then you start modifying into the modules that you want to do it. It's not a simple solution. I usually like to restart from scratch. I had a Terraform stack that was Terraform 11, and instead of migrating it all into Terraform 12, we just rewrote it from scratch because it was a bit of a rat's nest of implementation. And whenever we have customers, or what I've worked with customers which had big AWS estates and they wanted to move into the Terraform cloud, usually the best option is to start fresh and implementing the new architectures from the ground up on code and then migrating the data after the fact.
Are there any, what learning sources would you recommend for Terraform beginners in the audience, Luís?
Blogs and the Terraform learning page. So learn.hashicorp.com, I believe is it. They have great tutorials and wikis, and I have some blogs as well on how to start with it. Yeah, the internet is ripe for information. I'd say definitely start with the HashiCorp component documentation and the learning paths. And if you're feeling adventurous, go for the certification as well. It's really good thing to have under your belt.
Fantastic. I know that there's a few in the audience who are going through that certification at the moment. So well, that's all the questions. Luís, thank you ever so much for your time. For everyone in the audience, thank you ever so much for joining. You can follow Luís on Twitter, follow Luís on Medium and on LinkedIn. You can also follow myself and Bernd Sheehan on LinkedIn, where we'll be sharing our monthly newsletter, our insights and various blogs and news articles. If there are any questions at all, you can get in touch with myself, Oliver and Sheehan, or with Luís directly. Again, thank you ever so much, everyone, for joining, and yeah, hope to see you all soon.
Cheers, everybody. Thank you.
Thanks, everyone.